Let's see percentage purity. So percentage purity means how pure a substance is. So what you're going to do, you're going to find how much mass of pure substance you have over the mass of the total substance, the total mass of the substance, times 100. So one thing that you have to be careful when you're finding percentage purity is that if you have an impure substance, you cannot calculate the number of moles of an impure substance. Let's say I'm talking about tap water. Tap water is impure. So let's say I tell you you have 200 grams of tap water. You cannot do number of moles is equal to mass over mol for tap water, because tap water does not just contain H2O. It contains bacteria, it contains ions dissolved in it. So you don't actually know the mol of an impure substance. So number of moles is equal to mass over mol doesn't work for impure substance. So this applies only for pure substances. So let's see an example. So a chemist made 60 grams of aspirin. So 60 grams of aspirin, this is the total mass of the substance. Analysis showed that it contained 1.5 grams of impurities, which means that out of the 60 grams, there's 1.5 grams that are impurities, which means that you have 58.5 grams of pure aspirin only in that sample. So then the percentage purity is the mass of the pure substance divided by the mass of the total mass of the substance of the impure aspirin, which is 60, times 100. So that's 97.5%. Let's try to see example 2. Here you have impure copper heated in oxygen to form copper oxide. Now, if you look at the information given, you're given the mass of impure copper. You're given the mass of copper oxide. Now, it will be very tempting for you to use number of moles is equal to mass over mol here. Be careful. This is impure copper. Because it is impure copper, you cannot use number of moles is equal to mass over mol. It does not apply here. But because it produces copper oxide, this is a product. So the copper oxide is coming only from pure copper. So if you get the number of moles of copper oxide and you use the equation given, you can find the number of moles of copper. That would be, and if you get the number of moles of pure copper, you can get the mass of pure copper. And if you find the mass of pure copper, then you can find the percentage purity because you have the mass of impure copper. So let's work this out. So you have 3.2 grams of copper oxide. So you'll need mol. So number of moles of copper oxide is mass divided by mol. So that gives you 0.04 moles. We're converting to moles because in an equation you cannot work with mass. You can only work in moles. So from equation, the mole ratio CuO to Cu, 2 is to 2. So that's 1 is to 1, which means it's 0.04 is to 0.04 of copper. Therefore, the mass of copper, of pure copper, that's going to be number of moles times, in this case, AR, because copper is an atom. So 0.04 times 64. So this is the mass of the pure substance. Now, if you look at the mass of the pure substance, it should always be less than the total amount of the impure substance. So then the percentage purity will be 2.56 divided by the total mass, which is 4.3 times 100. So this is the percentage purity.